Hello, welcome to video number 3. We're going to start with percent. I'll be sending you some things over the weekend, quiz number 3 and a calendar by day for figuring out interest. But to start with percent, every rational real number can be written in 3 different ways: as a fraction, as a decimal, and as a percent. That's rational numbers. We're not worried right now about irrational numbers. They don't faze us right now. Okay, so the best example is if you have an exemplar. The one I always remember, and I'll leave it up here on the side, is the fraction's 1/2, the decimal's 0.5, and the percentage is 50%. Now, we usually use percentages for demonstration or comparison purposes, never used in computation. So how do we get to decimals? Long division. So let's take a simple one. Three-fifths. If I do long division, I get 0.6. And I'll just add the extra 0. So 3/5 is the same as 0.60. As a percent, we just move the decimal place 2 places to the right. Of course, the definition of percent helps us out too. So the definition of percent is X percent is the same as X divided by 100. So you can see that 60% is 60 divided by 100. That's the name of this decimal, 60/100ths, which we simplify to 3/5. 3 times 20 is 60, 5 times 20 is 100. So this is the same as 60 over 100. So these are all the same number, just different ways of expressing it. So if I have a decimal, it's really easy. To change that to a percent, I merely move the decimal place 2 places to the right. It still fits the definition. It's still 0.84 divided by 100. Which we wouldn't necessarily write that way. Not as a rational number. We would move the decimal place 2 places to the, we multiply by 100, in other words, numerator and denominator. And we would come back to the fraction, which represents the original decimal, 84/10,000ths. But if I write it like this, you can see that if I divided both numerator and denominator by 100, I could write the percent, X over 100. So it's X percent, 0.84%. So that fits this definition. So sometimes when the numbers are bigger than 1, you get a larger than 100% because 1 is 100%. You all with me on that? Yes? So 12 12.7 is 1,270%, because if I move the decimal place 2 places to the right, I would end up with this large percent. So you get the idea. So going the other direction, is also easy because you just move the decimal place the opposite direction. So move it to the left. And you can see that this is 45 100ths. That's the way we read that number. 45 100ths, which is the definition of 45%, 45 over 100. Okay, to calculate, we always have to change it to a decimal or a fraction. We can't calculate with percent. So if there's 250 milligrams of compound and 27.05 27.05 milligrams of hydrogen. What's the percentage? Well, I take the part that I know divided by the total. Of course, the milligrams would cancel, so I'm not going to write them. And when I do the long division, or in this case, the calculator, I would get rounded to the nearest 2 decimal places. Nearest 1/100th percent, so 2 decimal places. On the other hand, suppose that I knew that this was 1.94% chlorine. And I wanted to know how many grams of chlorine. So now is when I have to change the percent to a decimal, and I would multiply 250, the total number of milligrams, by 0.0194. I would change the percent to a decimal by moving the decimal place 2 places to the left. And if I do this in a calculator, I get 4.85 milligrams. So to the nearest 1/100th of a milligram, that was the directions. So you can go either direction. So you can see that what I said earlier, if you want a percent, you just do long division with a fraction. If you already have the decimal, then it's just a question of moving it the correct direction. From the decimal to the percent, you move to the right, because essentially your parts per hundred. When you have the percent and you want to go to the decimal, and you move back to the left. Okay. So that's our review for percent. Allow me to erase. So now we're going to open the subject of simple interest. There are a couple of rules that we have to remember by law. The banker's rule. For banker's rule, there's 360 days per year and 30 days per month. When you're talking about it as an abstract principle. In actuality, when you actually do the calculations, you just count the number of days there actually are. But when applying interest, you use the banker's rule. The 360 days per year is the one that's most important. So what is simple interest? We need some definitions. If you look at your formula sheet number 2, you'll see that I've laid them out for you on the front page. some of the definitions. I is interest. P is principal. Or P could be present value. It's what you start with right now. R is the annual interest rate. And T is the time. T is always and forever. Always, always, always measured in years. So that's where the banker's rule would come in. If you want to talk about, let's say the loan's for 75 days, then how many years is that? Well, it's 75 divided by 360. That's the banker's rule. So when calculating interest, we have a formula, simple interest formula. I equals PRT. I put the little stars in there so you see its multiplication. I equals PRT. So you just fill in the blanks. But remember, you got to change R from percent, because R can be given as a percent, so you got to change it to a decimal. So let's say number 1. So we have a principal. We start with $425. The annual interest rate is 1.92%, and the time is 6 years. How much interest will we earn? So we just use this formula. So I equals 425 times 0.0192. Make sure these decimals can be seen. Times 6. Put those numbers in the calculator and you come up with and don't forget your dollar sign. Remember, this is money. So I guess I should have a dollar sign in front of the 425, but we'll let you slide on that. But when you have your answers, your final answer should be in terms of money. And we always round to the nearest penny. 1/100th of a dollar. Okay, so that one was straight up. Let's try another one. So already you can see this one's problematic because I got a fraction with the percent and I got days. So let's take them one at a time. So the interest here will be 6712. So how do I change this to a decimal? Well, first of all, I can rewrite this. If you use your calculator, you'll see that 5/8 is 6.625. So we could do that. And then when I want to change it to a decimal, I move it to the left 2 decimal places. And then the last thing is 59, I got to divide by 360. So I'm not going to write it vertical because in a calculator you would write it horizontal. Order of operations won't be violated because we have all multiplications and divisions. As long as I do the division last, for sure there's no problems. And so for this one, if you work it out on the calculator, you'll get 28.87558333. And I don't want to forget my dollar sign. But now you see, I've given you the calculator answer. What do I do to it? I got to round it to the nearest penny. So the 5 makes the 7 into an 8. So $28.88. $28.88 will be the interest. Notice once again that for the time in years, it's 59 parts out of 360. 59 days is 59 divided by 360 years. That's the banker's rule. Okay, sometimes you'll see on the quiz, you have 4 items. We won't necessarily give you P, R, and T. We may give you 3 of the other ones, and one of them is missing. For instance, here I'm going to be solving for R. I'm given P, T, and I. So we want to solve for R. So you could do this literally as you could solve it for R, or you could do it numerically and solve for R. Either way. So let's do it numerically. So if I put in I, I'm not going to bother with the dollar signs because they'll cancel on both sides. So that equals P times R times T. So the easy thing to do here numerically is just to divide both sides by 1725 times 3. So I divide both sides of the equation by the same number. On this side, those cancel, and so I have R equals 82.80 divided by this number. Now if you do it on a calculator, make sure you put parentheses around it when you do it horizontally. In other words, it'll be 82.8 slash 1725 times 3. Because if you don't have the parentheses, it's going to do this division and then multiply by 3 instead of doing this and then dividing the product into 82.8. So when you do this, you get 1.6%. Actually, what number would we have got? That's the number we would have got, 0.016. And so to change it to a percent. Okay, here's one, number 4. P is $88,000, or I'm sorry, $800. R is 4%, and I is $64. So we want to solve for T. So I equals P times R times T. Right? So I will divide both sides by 800 times 0.04. So that cancels on the right, and so that's T. T is equal to, if you do the math, you'll get 2. So 2 years. Now, you may get 1.9999965, something like that. Well, that's significantly close to 2, so rather than say 1 year, 358 days or something like that, 359 days, we just go ahead and round it off. It's close enough for government work. We make it 2 years. Okay. So I'm going to end this video here. We're going to call this video 3A. I'm going to pick up again on video 3B. It's just easier for processing when I keep them around 20 minutes. So I will be back with video 3B. Hang in there.